Hello, I am Anuj Kumar. I am going to teach you LCR circuit, which is the part of the alternating current chapter. Okay, let's start the circuit. As you can see that the circuit which consists an inductor, capacitor and resistor is known as LCR circuit. This is L, this is C and this is R. And we know that the phasors diagram, along the inductor, the EMF lead with the phase pi by 2 to the current. In capacitor, electric current lead with the phase pi by 2 to the electric current. In capacitor, the current leads with the phase pi by 2 with the EMF, and in resistor both will be in same phase. So this is I and this is I. What about the inductor? We have already discussed this. This will it will be ahead of the current with the phase pi by 2. In capacitor, it will be lag by the phase pi by 2 phase difference, and in resistor it will be in same phase with the electric current. Okay, now as you can see that if someone asks you how much phase difference between the EMF across the inductor and the EMF across the capacitor, then you will say that you can see that EL and EC both are just opposite to each other. If we observe them along the current, then the phase will be pi. So the phase difference will be pi between EL and EC. Okay, now I am going to derive the formula for the impedance. What is impedance? Impedance is the resistance offered by LCR circuit. The resistance offered by LCR circuit is known as impedance. Let's find out. First, I am going to draw a triangle which is known as impedance triangle. Okay. EL, the EMF across the inductor, that is XL I naught, which is the value, well, we know the value of XL, that is L omega I naught. This is EC will be XC I naught. So this will be I naught upon C omega, and ER, this is R I naught. So we have the values EL, EC and ER, and you can see that EL is greater than EC. So if we draw the phasor diagram, then we will make more length of EL. It will be a longer than EC. So let's draw that. You can see here, this is EL, this is EC, and this is ER. Okay, as you can see that, and we have already discussed the phase between EL and EC is pi. What is the phase? EL and EC between pi. If I draw EC along the EL, then it will be in opposite direction, and this value will be EL minus EC. Now I am going to draw over here EL minus EC. So how we get the resultant? By this, and this is making any angle, that is phi, and this will be E is equals to EL minus EC plus ER. So how to find the impedance? As you can see that we can apply Pythagoras theorem, as both are perpendicular, but we will apply parallelogram theorem. Okay, see here, E square equals to EL minus EC whole square plus ER square. r square equals to root of a square plus b square plus 2ab cos theta. So theta is 90, so we apply here. E is I naught z. Now you have a question, why we put over here z? As I have told you, impedance, the resistance offered by LCR circuit, is known as impedance. EL, that is XL I naught minus XC I naught square plus ER, that is I naught R. Okay, now take I naught as common square, then it will become Z square is equals to XL minus XC whole square plus R square. So Z is equals to under root of XL minus XC whole square plus R square. This is the formula of the impedance. Yes, this is the formula of the impedance. Now you have a question. I know that your question is in your mind that, sir, how you will find that who will lead or who will lag? Like if current will lag or if current will lead, then how we will find? My dear, you must be remember that in inductor circuit, in capacitor circuit, in resistor circuit, firstly we have find the phases, the phase difference, and by the phase difference we observe that, we notice that which will be lead or which will be lag. Okay, let's find out. But before that, I want to tell you, let's find the condition. Let's find the condition by which the Z should be minimum and the current should be maximum. For maximum current in any circuit, the resistance should be minimum, and here the name of the resistance is impedance, and as you can see that impedance depends on XL, XC and R. And what about R? We cannot do anything, R, my boy. Yes, we cannot do anything. Why? Because every wire has a resistance, so we cannot ignore it. But we can do something with XL minus XC. Let's find out the condition by which the Z should be minimum. Okay, let's find out. For Z minimum, am I audible? Okay, Z minimum, XL minus XC, the whole square will be 0, maybe, then XL equals to XC, and XL, the formula is L omega, and this is 1 upon C omega. Omega square equals to 1 upon LC, then this will be omega 1 upon root LC. What? Root LC. So this is the angular frequency. I want frequency 2 pi f equals to 1 upon root LC. So f is equals to 1 upon 2 pi root LC. Yes, we get the condition. If we allow the current of this frequency in LCR circuit, then the impedance will be minimum and we get a maximum current. What we get? Maximum current, and in this condition the Z will be minimum, and this condition is known as resonance, and the frequency which is responsible for the resonance is known as resonant frequency. Okay, the condition in which the LCR circuit will get maximum current and minimum impedance is known as resonance, and the frequency at which resonance happens is known as resonant frequency. Okay, I hope you got it. So I am again repeating my thing. Yeah, at resonant frequency, if the current flow of this frequency, the impedance will be minimum and current will be maximum, and the condition is known as resonance and the frequency is known as resonant frequency. I hope you got it. As you have seen, we have find the condition of resonance. Okay, now we will find the condition when the current lag, and or the method how to find the phase. As you can see that we have a impedance triangle. This triangle is known as impedance triangle. impedance triangle. So we can find the phase over here. You can see phi, you can see perpendicular, you can see base. So you got something tan phi. Yes, a trigonometric ratio tan equals to base, sorry, perpendicular upon base. So let's find out tan phi, which is equals to EL minus EC upon R. Now what about EL? We know the formula I naught XL. What about EC? We know the formula I naught XC. I naught R. So I naught cancel and we get a tan phi. This is XL minus XC upon R. So this will be the phase. But our question was the same. How we will find the current is leading or the voltage is leading. So let's find out. Okay, if XL is greater than XC, then we will follow this. It means the circuit, LCR circuit, will be treated as inductive circuit and EMF will lead with the phase pi by 2 to the current, or you can say that the current will lag with the phase difference pi by 2. If XL is less than XC, then tan phi will be equals to XC minus XL upon R. Means if XL is less than XC, XC will be greater, then this value XC minus XL will become. Means this circuit, LCR circuit, will be treated as capacitive circuit, and we know that in capacitive circuit current will lead with the phase pi by 2 with the voltage. Okay, and what if XL will be XC, then tan phi will be 0 by R, then phi will be 0. Okay, it means the circuit will be treated as resistive circuit and I and E both will be in same phase. Okay, I hope you got it, how to find the lag and lead conditions, and how to find the phase, and how to find the impedance, and what is the resonance. So, okay. Now, one more thing. We can discuss the properties of resonant circuit. Like LCR circuit, you have seen that. So, there are so many questions. Like in LCR circuit, XL will be XC. Means inductive reactance will be equals to in capacitive reactance. Second, the current will be maximum, impedance will be minimum, power will be maximum. I and E will be in same phase. The circuit will be treated as resistive circuit, and so many properties.